Okay, hello, this is Dr. James, and today I'm going to show you how to build a super high power pulse transformer. This one's super high voltage, super high power. This has a ferrite core inside of it, and it's like a Tesla coil. And I have, let's just take a look here. I'll pull the core out of here. So we have a core wound inside, ferrite core. There we go. Okay, and I have 3D printed legs here, and I'll probably put the STL files for I did a couple different size tubing in the middle, some smaller core and then a bigger core, and I'll probably put the STL 3D printer files on Thingiverse and have links to that as well. So very cool, huh? Let's get started. Okay, it looks like it's finally arrived. Let's see what's in here. Come on. Okay. There we go. So ferrite core is very cool. Using these for cool projects. Okay. Excellent. Okay, so in order to make an impulse transformer, we need the transformer. This is going to be different than a Tesla coil. Tesla coil requires narrow resonance. You have to basically resonate it at its resonant frequency for a while for it to build up the energy. And it's very Tesla coils that cannot handle different types of impedances. If the impedance is not proper, so it can't build up a resonance, it will never build up high voltage. But a pulse transformer can, especially if you have a magnetic core. These are, I tried some other cores initially. Let's take a look here. Oh, come on, come on. Nah. Okay, these things are super magnetic. So this is just a metal iron core, and this one didn't work very well. And these are lossy. They produce eddy currents because they're actually metallic. When you pulse a transformer around them, the current will flow, and it will actually, you don't want current to flow in these things. You want it to, because that will kind of cancel out your magnetic field. Current flows in a way to cancel out the magnetic field. Ferromagnetic materials, which these are, but this is too conductive, enhance the magnetic field. And so this is a ferrite, it's a sintered ferrite. And my first set of experiments is just with a single one of these. And I have some super high voltage wire here. So I just put some windings around this. I think I had about 10 windings or so around the first core that I tried. So I'll wind it up around the center of it and then place it inside of our transformer here. Okay. And here's a core that I used later in the video where I went from one of these inside of the windings to 4 of them because I was kind of saturating the energy density of just one of these. And so let's get going. Okay, so here's one of the 3D printed legs, and the coil kind of goes in this side. I have 2 of these. You put one on each side. The coil will fit right in there, and I believe this is what, a 3-inch PVC pipe. It's a little bit bigger, so when you wrap wires around it, it'll fit inside of there. And I didn't put a hole in the top. You could probably, I could have designed that in there, but I just drilled it afterwards, so you can drill whatever size hole you want. But so the legs, this is what it looks like. This is for the smaller tube. I have new legs for a bigger tube that can go in the bigger, in the center of this, so I can put a bigger core in there because a bigger core wouldn't fit in this smaller tube. And here are some of my PVC pipes that I use. This is the larger one, and this is what, I think 1.5 inch diameter. Does it say on there? Anyway, and I think the other one here is a 1-inch diameter. I'm not seeing it on there. Yeah, 1 inch. Okay, so And these go inside the center of the legs, like so. So your coil would go around the outside, and then this would be insulate. Here, let's see. Insulate the inner windings from the outer windings. So you can run that through the center. And let's see, that's what I did here in my coil. So I have this, there. The tube goes through the center here, and then this outer one holds the bigger tube up there. And so that's how that works. And I'll probably be posting links to these on Thingiverse if you're interested in printing your own. I'll put both sizes on there. So you want to print two of the same size if you're going to, because you just got to choose which size pipe you want. Don't print one of each, because one pipe will fit in one and it won't fit in the other. Okay. Okay, here's some initial testing of our high voltage pulse transformer. And this is a 15 kV capacitor with, let's see, I don't know if I can read that. Okay. 102M. I forget what that is. It's microfarads, I think. 2 is the multiplier. Anyway, let's just charge this thing up a little bit. Okay. And we'll discharge this and take a look at the spark. See the spark on there? Where's the spark at? Okay, there it is. Oh, there we go. So that's about a centimeter spark across there. Okay. Yeah, so we're getting about a centimeter with our ferrite core. Okay, that's 10 turns on the input. Take a look at the core. Okay, so here's the coil and here's the core. The core is a little bit shorter than what I like. It doesn't go the whole length of the coil. I have about 10 turns. These cores are a little bit smaller than I thought they're going to be, so I put 2 of them together in parallel. And this produces about a 1 centimeter spark of the coil. Okay, so I tried doubling the capacitance, and the spark is even longer now. Okay, let's get a closer view on this. Okay, I'll try charging this guy up. Okay. And let's take a look at the spark here. Look at that. Much longer spark now. Okay. I made the spark gap even bigger yet. And look at that. Wow. So that's just with 2 of these capacitors. Okay, so I've got about 3 of these capacitors now. And I increased the spark gap to almost an inch. Let's try that again. Okay. go. So it's making a spark all the way across, almost an inch. With 3 capacitors. Okay, again, here's our 3 capacitor setup. And the calipers trying to measure approximately what that gap is. Okay. So what is that, about 16 millimeters maybe? Okay. So 16, a little bit over 16 millimeters maybe. It's hard to get an exact measurement of that. So that's about 5 millimeters per capacitor. Actually, I got a little bit more accurate measurement. It looks like it's about 17 millimeters. Okay. Get a little bit closer in there. Okay. Very cool, huh? Okay, so I'm just measuring the capacitance of this capacitor, and it looks like it is 800, about 800 picofarads, a little bit over. Okay, so that's good to know. Okay, so it looks like 4 capacitors is able to do pretty much an inch, 26 millimeters. Okay. Okay, here we go. There's our spark gap. Try it again. There we go, 1 inch spark. Wow. Okay, so here is a 30 millimeter spark gap on the output. Okay. Okay, definitely a spark going between there. Very cool, huh? Okay, so here we go. We got a spark gap of 34 millimeters. Wow. And put a high impedance resistor in there, high voltage resistor. Let's just take a look here. Look at that. Wow. Lightning bolts, huh? Okay, so now we're up to 7 capacitors. And here we have the spark gap set at about 42 millimeters. And let's give this a try. Turn on the high voltage. Okay. Okay, there, I think I saw an arc go across. There, yep, there was an arc. Probably at the limit there. Okay, so here is my new core. It's got 4 of these rods in it. And just want to make sure it fits into my core holder, which also acts as insulation from the high voltage. 1.5 inch diameter PVC pipe. Okay. Okay, excellent. Things are looking pretty good. Okay, so I made some new coil legs so I can put a bigger PVC pipe through there. And again, this size here is, let's take a look. This is the other side of it that I cut off. It's 1.5 inch PVC. Okay. And here we have our new coil core. Oh. Here we have our new coil core. I put 4 cores in there. And let's, I guess, run this guy through the transformer. Come on. And we'll give this guy a test to see how it works. The core kind of in the middle of the coil. Okay. Get it centered in there. Okay. And maybe I should have put it through the other way because I want this side to have a shorter lead and that one to have a longer lead, I think. Okay, well, let me just reverse that. We'll give it a test. Okay, so I left the calipers at the same setting, and I readjusted the spark gap, so it's a little bit skewed, but anyway, so there we go. It's about 40, almost 45 millimeters, around there. Okay, and we'll give this thing a test. We'll see how this works. Let me get that over there. Okay. And we'll turn on our high voltage power supply. Oh, wow. I think the spark's a lot stronger now. Wow. Very cool, huh? Okay, I have about 58 millimeters now. And let's check this out. Oh, look at that, it arced across. 58 millimeters. Okay, it's not arcing every time though. Okay, again, we're still at 58 millimeters, and I added another capacitor, so we're up to 9 capacitors now. Let's get our power supply turned on, and there we got a regular spark now from this thing. Oh, look at that. Yeah, nice long spark. The camera's picking it up, but I can definitely see it. Wow. Pretty incredible, huh? Okay, I made a new core. It has four of these small cores in it, and it only has 4 windings. The other one had 10. We'll see if that steps up the voltage more or if we just get more energy losses. Okay, it should be interesting. We'll check that out. Okay, so I have my new 4-turn core in there, and we'll try charging this up. I have the same spark gap, which I believe was 63. Yep. And we'll just test this out. Okay, it looks like it's breaking down at least at that voltage. Let's try it one more time. Definitely getting a nice lightning bolt across there.